Okay, I wanted to do a quick video to recap some of the main themes that are coming up for the second piece. So one thing that we wanted to bring out, when we have the derivative of an integral, and let's keep it as generic as possible here. We got g to the x, h to the x, and f of t dt. Okay. Now in this situation, an important thing to remember is that this, generally when we talk about the this integral here, the of f of t dt, we can denote this as the function f of t, like that, big F of t. Okay, so that's an important thing to remember, is that this just means the antiderivative. This is the antiderivative function here. So now when I'm looking at this, I'm going to go ahead and treat this as an antiderivative first here, that doing the inside, just in light of this right here. So that means I've got my f evaluated at h of x, right? And then minus big F evaluated at g of x. Okay, that part. That's just based off of this idea. Now the nice thing about that is we can also remember that since this is an antiderivative, that if I take the derivative of f of t, big F of t, I should get back little f of t, right? Okay, so now using that idea, I've got the derivative of this and then minus this, so derivative of this minus the derivative of this. So I'm going to do that. Well, the derivative of big F is just little f, so I've got little f h of x, but then remember we've got a function inside here, so we've got the chain rule, so like that. Okay. And then, actually don't need that extra one. Then minus, same thing, little f of g of x, then times the derivative of the inside, so g prime of x. Alright? So that means when we have the derivative of an integral, this is our most generic form. Now if this is a constant or this is a constant, then your derivative here or here is going to be 0. So of course that means that that whole thing is gone. So if you have a constant here or here, you don't have to worry about the extra part. And then also if this is just x or this is just x, then the derivative here is 1, so you've just got f of x. Good. Okay, that process makes sense? Okay, another thing to think about that we'll deal with from the practice. Let's go ahead and erase this. Okay. So say we've got some function, some integral, and we don't know it. Let's say 1 to 3 of some function, and they give us a value. Okay. So they give us this value, say 30. Okay. So we have this. What we're saying is the area under this function from 1 to 3 is equal to 30, right? So we've got some function, and then from 1 to 3, we take the area under here, and we get 30. Okay. So now if I know another bit of it, you know, say I know from 2 to 3 of this function is 12. Well, from 2 to 3, that's from here to here, that's the area under here. So if this much is 12 under here, then that's just 30 minus 12 to get this piece over here. So I would be able to tell what 1 to 3 is. of g of x. Right. It's just the subtraction problem there, which is 18. Okay, dx. Alright, that makes sense? Now that works exactly the same as if you have, you know, it might have been negative, so if this were negative 12, perhaps, then what that means is somewhere my function goes down here, but then that would just be, I'm still subtracting a negative 12, so I'd be at 42 in that case. Okay, but the same ideas. Okay, then another thing that comes up is the average value. And the average value is just exactly kind of what we normally mean when we add up all the bits and then divide by how many we have. Well, in this case, when you're trying to find the average value of a function, say we've got f of t, we want to find the average value over a certain place, say from A to B. Okay? Well, what we can do is we can take the integral from A to B of f of t and then divide that by the distance from A to B. And that's going to be our average value. Okay? Good. Okay. And then kind of related to the stuff we were talking about before, if we're using this notion that basically that big F, if you take the derivative of big F, you get little f. So if I want to know, say I have a graph of function of f of x, like this. Let me make it do something a little different. Say it goes like this. Okay, if this is little f of x, and I want to know what the critical points of big F of x are, so big F of x, critical points, then all I need to do is remember that our critical points are when our derivative is equal to 0. So where f prime of x equals 0, well, f prime of x is just f of x, so that's where f of x equals 0. So that's going to be here, 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 and here, right? Those are my critical points. Okay, and then you can see whether they're max or min. And then in the same way, if you want to know where the max and min are, well, that's where the derivative, or inflection points of f, well, that's the double, where that equals 0. Those are inflection points. Well, that's also the derivative, where the derivative of x equals 0, which are just the horizontal tangents. Or really local max or min of the, so we have a local max here, we have a local min here, we have a local max here, we have a local min here. Okay. Now this also happens to work if this was like a corner here or a cusp, that would still end up being it's a local min for us, so it would be a critical point or a possible inflection point. Okay. Good. Okay. And then just one last bit here. All right. Okay. So another thing to remember is when you're dealing with a function, so say I have function I of x. I can define it. I can define this function in a lot of ways. And one way to do that is say I can do something like this, where it's from a to x here of the sum function evaluated t. Okay, something like that. So what this means is, from a to some other value, I want to know the area under this curve. So if I say I of 1, well then that's just from a to 1 of whatever that function is. Okay, so it can be evaluated just like that. So you just plug in wherever, since this is x and this is x, when this is 1, this becomes 1. And you could do that for anything. I could even make it a new function. I could say, what's I of g of x? Well, then I would just put in g of x, f of t, dt, and move on like that. So you can do that however you like. And hopefully those reminders can help you a little bit as you prepare for the exam.